Okay, so section 1.2, ordered pairs as points. Okay, so the first couple things I'm going to have you write down are some definitions. Ordered pairs, not really a definition, but what you kind of need to know about that is you're always going to have an x and a y. Your x is going to be horizontal, so your x direction when you graph is always going to be right and left, and then your y is always going to be vertical, so it's what you do up and down. Okay. Now these other ones here you probably have to look up in the book. So plane coordinate geometry on page 13, standard form page 13, Euclidean plane geometry on 14, and then we'll stop there and I'll talk through those. So get those jotted down and then I'll talk through what they mean. Okay, so the first one, plane coordinate geometry on page 13 says, when I flip to it, it says the study of geometric figures using points as ordered pairs of real numbers is called plane coordinate geometry. Okay, so coordinate geometry is basically when we use things like a graph, kind of like here. This is a coordinate plane, so they're talking about anytime we use ordered pairs and make lines and do that kind of thing, that's Euclidean geometry. And basically Euclidean geometry is the kind of math that you would think of in general. It's nothing that's different. It's kind of what you've been using probably your whole life to do math. The next thing there, standard form, it's just a certain way to set up an equation. So standard form is where you'll have a number here for a that goes with the x, so a coefficient, so it could be like 3x plus, and then b would be a number as well, so maybe 3x plus 4y is equal to, and then c is also a number, maybe 5 or something like that. That would be standard form. Next one there, Euclidean plane geometry, or plane coordinate geometry, it says, this is again where it says our description of our point and description of a line. So for that it says a point is an ordered pair of real numbers, okay, so kind of like what we talked about before, ordered pair, your x and y. And then description of a line is a set of ordered pairs of real numbers, x and y, satisfying an equation in the form, and then it lists out the standard form again, where a and b are not both 0, okay? And if you think about it, why they say that there, well, if a is 0 and b is also 0, well, 0 times anything is 0, 0 times anything is 0 there, so that would just be 0 is equal to, and c is another number, so maybe 0 is equal to 5, well, that doesn't really make sense for a line. So those both can't be 0 at the same time. Now one of them could be 0, and that's kind of what happens down here with this next thing. So on page 14, there should be 3 pictures kind of towards the top of the page where they've got one that's a horizontal line, one that's a vertical line, and then one that's an oblique or like a diagonal line. I would jot those into your notes and then also put the equation that goes with it. So like the first one for the horizontal, I would just sketch something kind of like that for my graph, and then maybe you want to do like in a different color the line that they're talking about. So that would be a horizontal line, and then where they get their number for like the y equals, they have 1.5 there for theirs. They're getting that from where it crosses that line right there. So where it crosses the y-axis is where they get that number. Okay, and then for your vertical one, for the next one there, again, I would just sketch it. You know, something like that, and they have, what do they have? X is equal to -3. So what that means is that's going to be a vertical line through -3. So that point right there is -3. Okay, and that point right there is 1.5. Okay, so that's kind of how they're coming up with that. Now an oblique line would just be kind of a diagonal line. So it could go any way. What ways theirs go? Oops, I didn't draw the other one in, did I? An oblique line would just be something that kind of goes diagonal, wouldn't be horizontal or vertical, and then it's going to be written in standard form, something kind of like that. So they've got listed is x plus y is equal to 3, but in any case, as long as there's both of those variables there, x and y, then it's going to be an oblique line. Okay. So the next thing here, slope-intercept form. So this is the one that I probably most commonly use, and there's probably a definition for it in the book too. But slope-intercept form is where you've got y is equal to mx plus b. Your y-intercept is what the b is. So when they're talking about y-intercept would be where it crosses the y-axis. So like back to this graph here, wherever it's crossing right there, that's your y-intercept, because this is the y-axis. So wherever that diagonal line or whatever kind of line is crossing the y, that's your y-intercept. Okay. Now your slope is your steepness. So like how far up and over you've got to go, and if it's like super steep or if it's less steep, and then which direction it's going as well. Because this would be a negative slope because it's going downhill. If we had a line going that way, that would be a positive slope, and we'll talk about that kind of down here. But that slope-intercept form, it's always going to be y equals, then your m is always going to represent the slope, then the slope is always going to be with the x, and then it's always going to be plus your y-intercept at the end. Okay, and we'll do some problems related to that as well. Okay, to calculate slope, what you want to do is it's the change in y over the change in x. Okay, so change, to calculate change or difference, we would subtract. So you're going to take the difference of your two y values, so y1 and y2 from the ordered pairs, and you're going to subtract those on the top. Then to figure out your bottom number for the fraction, you're basically going to take your x's and subtract those. Now why they have 1s and 2s with them, it doesn't, like the number doesn't matter. What they're telling you is that these two are grouped together, so x1 and y1 are grouped together. So when you put them into your problem here, they've got to be stacked together. Okay, so if you start with this ordered pair, the x2 and y2, you have to like keep that together as well, like stacked on top of each other. So if you start with, you know, the second one, you also have to start with the second one on the bottom. And you can start with the first one as well. It doesn't really matter. Usually books write it out like that, and I have no idea why. Okay, next thing, another way to look at slope is your rise over your run. So now when I'm talking about that, so say I've got a line like that, and I've got a point right there, something like that. Okay, so now when we're talking about rise over run, say we start at this point here, we're trying to figure out how far we rise and how far we run, and that would be slope. So now if we're going up and to the right, that's going to be positive. Now some graphs you'll run out of room doing that, so you'll have to go the other way, but if you go down and to the left, that's also positive. Okay, now why that works is if you go up and to the right, up is positive, right is positive. So if your rise is a positive number divided by a positive number, you're going to get a positive answer. Okay, same with here. If we start here, we go down, down is negative. If we go to the left, that's negative. So if you do a negative divided by a negative, that also comes out to be a positive answer. Okay, so that's how that works, that you can go both ways with that. Now a negative slope, so I'm going to do it down here. Am I going to do it right there? I'll do it over here. So negative slope be going that way. So again, you got your points there. We'll go off the middle one. So with this, if we do rise and run, our rise, see how far we go up, and then our run, see how far we go over to the next point. Well, if we're rising, it's positive, and if we go to the left, that's negative. Same thing here, if we start at that middle point, go down, well down is negative, to the right is positive. In this case, our rise, positive, so we do positive divided by a negative. That always comes out to be a negative. In this case here, our rise is going down, so a negative divided by a positive, that also comes out to be a negative. So in a case like this, when we're going downhill, that's always going to be a negative number. Okay, so that's kind of how that works out. But positive, always going to be uphill. Negative, always going to be going downhill. Okay? Alright, so the next thing they want us to do here is to graph an equation. So we've got y is equal to 3x plus 1, and this one's good to work with because it's already in slope-intercept form, and slope-intercept form is really easy to graph out of. Well, not really easy. It's really easy after you practice it for a while. Okay, so we've got y equals, and we know, thinking back to that equation before, when we've got y equals mx plus b, the m is always our slope, and the b is always our y-intercept. Okay, so in this case, our y-intercept, or our b, is going to be 1. I'll put that here. Our y-intercept is 1, and our slope is 3. And typically when we work with slope and we're going to graph it, usually you see it as a fraction, so your top number is your rise, and your bottom number is your run. And you can always take a number, so if it's a whole number like that, like 3, you can always take and put it over 1 to make it a fraction. Okay, when we graph, we always start with the y-intercept. That gives us a starting point to do the slope off of. Okay, so what we're going to do is we're going to go to our y-axis, which is our up and down one, and we're going to go to 1, stick a point. Then we're going to do our slope, so we're going to have to rise up 3 and run 1 to the right, okay, because right is positive. So we're going to rise up 3, so 1, 2, 3, and then we're going to run 1 to the right. Okay, and then from that point we just made, we could do that again. So we rise up 3, 1, 2, 3, and then go over 1 to the right. Okay, whenever you're graphing lines like this, you want to do at least 3 points, because 3 points makes a good line, and just to check yourself to make sure that you're doing it right. And you can also say, you know, we went to do that again, maybe we ran out of room doing it that way. We could also go down. So if you go down, that's negative, so 1, 2, 3, then you would have to go left, because if we rise negative, so like if you went down 3 and then you go to run, well, to get this back to a positive slope, which it is, you would have to go a negative, because if you do negative 3 divided by negative 1, you still have a positive 3, so your slope is still positive 3 there. And you could do that again if you wanted to, down 3, 1, 2, 3, left 1, and then all of those points should connect into a straight line. And if it's not a straight line, then something's wrong. Okay, try another one here. Okay, so this one, it says write an equation of the line that contains the points 4, 2, and 1, 8. Okay, so they just give us points on a line, and we've got to come up with an equation for that. I typically like to work with slope-intercept because I think that's the easiest, and usually it's the only one I can remember. So we're going to have to come up with the slope, and we're going to have to come up with the y-intercept. Slope is the easiest thing to find first. Okay, so what we're going to want to do is we're going to want to use that slope formula, which was the y2 minus the y1 over x2 minus x1. Okay, so it's always the y's on the top, and that's a big mistake that people typically make, is they want to put the x on top because it comes first, but always remember that it's rise over run, and the y is our rising. Okay, so our ordered pairs here, we got 4, 2, 4 is the x, 2 is the y, and then 1, 8, 1 is the x, 8 is the y. Okay, so if I take and I plug that in there, so y minus y, so if I pick, say I pick this y first, 2, so if I did 2 minus my other y, which is 8, over, and then if I chose the 2 first, I have to choose the 4 first, okay, that's important. You can't just choose the 2 and then flop over to this one. If you choose the 2 first, you've got to choose the 4 first. So then you do 4 minus, and then your other x is 1. Okay, and then if we solve that out, I always like to turn my subtracts to adding the opposite, which you don't have to, I don't really care, but it's easier for me. So then I do 2 plus a negative 8, which would be negative 6, over, and then here we would do, really I probably shouldn't have switched this one from subtract, but 4 minus 1, or 4 plus a negative 1, would be 3. And then if you take and simplify that down, well, negative 6 divided by 3 would come out to be negative 2. So your slope in this case, and I should have put an m here, our m, which is slope, comes out to be negative 2. Okay, so we're part way to getting this figured out here. Okay, so now if we go back to our equation here, so y equals mx plus b, well, we just figured out our m was negative 2.